Hi everyone. So in this video we will be discussing this specific heat and calorimetry lab. In this lab you will learn more about heat transfer, calorimetry, which you've already most likely maybe touched on in the lecture material, but you will actually get to perform a calorimeter experiment and also you will get to determine a specific heat capacity of a liquid. So there's two major parts to this lab. As always, you know I like to split up like bigger themes. You will be doing that calorimeter experiment and then you will be determining that specific heat capacity of a liquid. So just to kind of get that going in your mind, splitting it up in those two major sections. So as always, intro has really useful information about thermochem, about the relationship of energy between system versus surroundings, right? Energy is neither, created or destroyed. It's simply transferred from one, you could say thing to another thing. So from the system to the surroundings, right? Or the other way around. And then we go a little bit into what specific heat is here. And then we go into our favorite equation, Q equals MCAT. So that's a common way to call this equation just because that's kind of how it looks. The delta looks like an A, and the delta is right there, right? It looks like a little triangle. But that's often, you'll hear it called that way. But what it symbolizes is, your energy equals your mass times your specific heat times the change in temperature, right? And because we know that heat is simply transferred from, system to surroundings in whatever situation you have, we can set these equal to each other. So the MCAT on one side equal to the MCAT on the other side, right? Except the opposite in signs. And here I describe the units. So overall, in the first part of the experiment, we're looking at calorimeter experiments. In the first part of this lab, in the first part of this lab, calorimeter experiments, how calorimeters work. Today I am obviously very tongue-tied. And then in the second part of the lab, we are looking at an unknown liquid called compound Y, and we are going to determine its heat capacity. So part one, you're going to open up this Pearson virtual lab. If you're curious about how to click on links, you just press Control and then click the link with your cursor. So I did that. And then let me refresh this page so you can actually see how it would look. So this is what you would see: an overview, learning outcomes, and experiment. If that's what you're going to click on, okay? Now, before we go further, let me actually discuss the procedure a little bit more. So this first entire portion here, I should have bloopers in these videos because I'm always messing up. Anyway, hopefully you get a laugh out of it. Steps 1 through 9, you are essentially learning how the simulation works, because this one is a little bit more finicky than Chem Collective. I think Chem Collective is pretty easy. There's no like weird workflow where you have to press one button first, and you'll see right now in this lab there kind of is. So let's go through that, and then you will repeat everything in steps 2 through 8 essentially, and that's where you're collecting your data. So I'm going to go back to my lab. So when you load it, it should look like this. Then you click experiment. You're going to click run experiment, and you're going to see this setup. So this is your actual calorimeter, and the purpose of a calorimeter is to be able to measure energy changes in a closed environment. So this, you'll see that it closes. This is like a lid. Here, this is just where we are weighing I really can't talk today. Our first substance. Now, by substance, you can either choose a liquid, a solid, a solution. I am just going to choose, actually, I'm going to choose a solid. So we're going to choose, and I'm just going random because I'm just showing you an example, right? Let's do copper. Now, notice that the next thing that toggled where I could click is this little bar where I can increase the mass. So I'm just increasing to a random mass. And then the next part that you could click is the temperature. Now, I also want you to click the specific heat. That's going to be important, or you're going to need that, right? So just adjust all of these. So you're going to click that. You're going to adjust the mass to whatever you want, the temperature to whatever you want. Then you'll notice, or you probably noticed, that this button showed up as soon as I adjusted the temperature. So you're going to click next. This takes you to the second portion where you select a substance for the calorimeter. So notice how that is there. Now you need something here. So I'm going to choose a liquid for this one, water. I'm going to adjust the mass. I just chose random amount and show specific heat. So just adjust whatever it lets you. And it starts off at 20 degrees C. And then you probably noticed that this next button showed up. And then the animation can begin and you can basically run the experiment. You're basically all set up. So what you're going to do is just show the graph view, show microscopic view so we can have some more information. And you are going to press start. So then they added the copper to the calorimeter. They closed the lid and now the reaction is occurring. The temperature is being measured. In other words, the energy, right? Because temperature is a measure of energy, measure of kinetic energy. Notice that the copper was at a high temperature and it decreased to a lower temperature, right? Versus water, it increased a little bit. Hopefully you were looking at the molecular view as well, but you could replay it here if you want, and you can also reset here. So whenever you do your actual first trial, you're going to reset, okay? But that's how you work through this lab. Like I said, there's just some buttons and there's an order of things that you have to choose, but hopefully it's not too bad and not too tricky. So that is part 1. And you're going to repeat these steps for the following combination. So you're going to choose a liquid and a liquid, a solid and a liquid, liquid solution, and you get the point, right? You're going to choose all these different combinations. You should be able to choose all of them. If you can't for some reason, just let me know and we'll figure it out. You're going to record the substances you used. You're going to record the amounts, the starting temperatures, and the final temperatures of everything in table 1. And then you will also show screenshots or insert screenshots of the experiment. So once we get to the data collection portion, I will talk more about that. So let's go into discussing the procedure of part 2. So I have this virtual lab open as well here on another tab. I had some trouble opening this one up just now. All I had to do was press refresh and it went ahead and behaved and it opened. So you should see the title measuring the heat capacity of an engine coolant. So that's actually what we're working with. But you actually don't know the value for the specific heat. So that's what we are determining. So let's go back to the procedure. We have compound Y. Hopefully you just saw it. But you're going to bring both to your workbench. And what I really want to show you here is an important step in this entire process. Everything else, honestly, you can just read the procedure, and I think everybody's pretty good with Chem Collective at this point. But this is the part, step 3. This is the part that I really want to emphasize, just because it is going to be so important for your readings and your information and the data you record. Okay, so right click. Anytime you need to reach thermal properties, you're going to right click. That's what I was doing just now. And this right here, this option, thermal properties, click that, insulated from surroundings, and press OK. That is important. I keep going to the wrong screen, I'm sorry. So that is important because you need to maintain a closed environment for this type of experiment. So that's why we went ahead and insulated it from surroundings. Okay, you can also choose a temperature. So for the compound Y, you are going to choose between 30 and 90 degrees. Okay, you can choose whatever you want between there. So that is the major point I want to highlight or emphasize, just because that's something that you probably haven't used in Chem Collective. The rest of Chem Collective, bringing over to Workbench, accessing the information tab, and let me just, accessing the information tab, bringing things over to the Workbench. I feel like everybody's pretty competent with that at this point. So I will let you complete the rest and go through these steps. The last part of this portion of the lab the last step is to calculate the heat capacity. So I kind of outlined the steps for you, so hopefully these help you. But essentially we're using this equation where we set one side to the water and the other side to our compound Y. We don't know what the heat capacity is. That CY, that's heat capacity of Y, is what we are solving for, okay? So just to show you how the data collection looks, for part 1, this is where you're collecting all the values, all the measurements, and then here is where you're inserting the screenshots that we were discussing. For part 2, again, you have to measure everything, collect all those measurements, all the units, and then you're going to calculate those specific heat, the masses, and everything. So you can actually work on the calculations first and then fill in this table. It's up to you. But make sure to show all your calculations right here. And then finally at the end, there's just some short problems on that you will solve on heat capacity and heat transfer. So just make sure to show all calculations necessary, and if you need to answer questions in sentences, please do so as well. So as always, if you have any questions at all, just let me know. Thank you.